Most people assume pioneer households were just dirty. And honestly, given what they were working with, that assumption seems reasonable. No running water, no grocery store cleaning aisle, no spray bottles, no paper towels. But if you actually study the domestic records, the household journals, the farm manuals from the 18th and 19th centuries, you start to realize something. These households were not filthy by choice or by ignorance. They were clean by method. Hard, physical, time-consuming method. The tools were different. The chemistry was the same. What interests me is not that they survived without store-bought chemicals. It's that some of what they used actually worked well. And some of it worked for reasons they didn't fully understand, but stumbled onto anyway. And a few of these tricks are still genuinely worth knowing. If you're off-grid, homesteading, camping long-term, or just curious about what your options are when the cleaning supplies run out. Hit subscribe before we get into it. This channel covers practical frontier history without the romanticized nonsense, and there's a lot more where this is coming from. I'm Jerry Davis, and I've spent years studying the tools, methods, and daily routines people depended on before modern household products existed. What I keep finding is that the gap between their knowledge and ours is not as wide as people think. The chemistry of cleaning has not changed. Water, acid, alkali, abrasion, heat. That's still the whole game. The pioneers just used different sources for each one. By the end of this, you'll understand what each of these 8 methods actually did, why some worked better than others, which ones have real limitations people tend to gloss over, and which ones are still worth using today. Let's get into it. Asterisk number 1, wood ash lye water. AS. This is probably the most important cleaning material in a pre-industrial household, and almost nobody today understands how it actually worked. The common version of the story is that people just sprinkled ash on things and called it clean. That's not quite right. Here's what was actually happening. Wood ash, particularly ash from hardwoods like oak, hickory, or beech, contains potassium carbonate and calcium oxide. When you pour water through a pile of wood ash and let it leach through, what drips out the other end is a strongly alkaline solution, often called lye water or potash lye. This liquid is caustic. It reacts with grease and fat and breaks it apart through a chemical process called saponification, which is the same basic reaction that makes soap. Period household manuals described leaching barrels specifically for this purpose. A wooden barrel with holes in the bottom, packed with ash, positioned over a collection vessel. Rainwater or poured water would slowly pass through the ash column and collect below as a potent alkaline solution. That lye water was used for washing laundry, scrubbing wooden floors, cleaning cooking pots, and processing animal hides. It also went into the soap-making process, which we'll get to in a moment. Now here's the part people usually leave out. Lye water is not gentle. Concentrated lye water can burn skin. Period. Accounts mention washing hands with diluted versions, but being careful about letting strong lye sit on bare skin too long. It was effective precisely because it was chemically aggressive. Using it carelessly was a real hazard, especially for children and for people working with it in large quantities over a fire. The practical takeaway is that wood ash lye is genuinely functional. It's not folklore. The chemistry is real. And the household chemistry books from the 1800s that describe it are describing an actual working process. If you're in a long-term off-grid situation without cleaning supplies, this is worth understanding. But handle it carefully, dilute it appropriately, and don't let anyone tell you it's just a mild, natural cleaner. Mild is not the right word. Number 2, rendered fat and lye soap. Datist. If lye water is the chemistry, rendered fat is the fuel. Combining the two produces soap. This is one of the oldest known chemical processes humans developed, and frontier households relied on it as a primary cleaning agent for skin, clothing, dishes, and floors. The fat, came from whatever was available. Beef tallow was common. Lard from pigs was common. Bear fat was used when available. The fat was rendered, meaning cooked slowly to remove impurities and water, and then combined with lye water in specific proportions and cooked again until the mixture reached a consistency that would set into a usable soap. The result was typically a soft soap, which looks almost like a thick gel rather than a firm bar. Hard bar soap requires a more precise lye concentration and the right fat ratio. Soft soap was still effective for laundry and general cleaning. It was applied directly to fabrics, worked in by hand, and then rinsed. What made this practical was that both raw materials, fat and wood ash, were byproducts of everyday frontier life. Every time you butchered an animal, you saved the fat. Every time you burned wood, you had ash. Nothing was wasted. The soap-making process converted materials that would otherwise go unused into something with direct household value. The limitation is time and labor. Making soap this way is not quick. It requires careful handling of caustic materials, of fire, sufficient fat, and patience. The finished product also does not have a consistent concentration the way commercial soap does, which means you have to learn by feel and experience what works. Still, this is a legitimate survival-level skill. It's not a weekend craft project. It's a real method that produced real soap that kept households clean for generations. Asterisk number 3, sand and fine grit scrubbing. This one sounds primitive, and in some ways it is. But abrasion is a legitimate cleaning mechanism, and frontier households used it systematically. Fine river sand was used to scour cast iron cookware, wooden cutting surfaces, stone hearths, and brick floors. The sand acted as a mechanical abrasive, physically removing charred food, grease, and staining from surfaces that couldn't be soaked or submerged easily. Wet sand applied with a rough cloth or a bundle of straw could clean a cast iron pot effectively. Sand was also combined with other materials. Some period domestic manuals described mixing sand with wood ash, which combined the mechanical abrasion of the sand with the alkaline grease-cutting action of the ash. That combination could clean heavily soiled cookware without any commercial product at all. For cast iron specifically, this is actually still good practice today. Many modern cast iron cookware guides recommend avoiding soap because it can break down the seasoning layer. Coarse salt, which we'll get to, or fine sand with hot water will clean cast iron without stripping the polymerized oil layer that makes it non-stick. The downside is obvious. Sand is not a universal cleaner. You wouldn't use it on fabric, on delicate surfaces, or on anything you wanted to keep smooth. It scratches. Used on wooden surfaces repeatedly over time, it will wear them down. Used on soft wood cutting boards regularly, you'll eventually sand the board flat. But for heavy-duty work, cast iron, stone, and brick, abrasive scrubbing with materials like sand, crushed walnut shell, or coarse salt is still a genuinely functional approach. Number 4, vinegar. Data Addicts vinegar is the one item on this list that people are still using today, and for good reason. Acetic acid, which is the active component in vinegar, is a real antimicrobial agent. It's effective against a range of bacteria and mold species, though it's not a hospital-grade disinfectant, and it doesn't kill everything. Frontier households produced vinegar from hard cider, wine, or fermented fruit, and they used it in a wide range of cleaning applications. Wiping down wooden surfaces, removing mold from walls and fabrics, rinsing glass, and treating fabrics before washing were all documented uses. Vinegar was also used in the laundry rinse water to neutralize any remaining alkaline residue from lye soap and to help fabric fibers relax and release dirt. The antimicrobial properties of vinegar were not fully understood in chemical terms by people in the 18th century, but they were observed empirically. They knew that surfaces wiped with vinegar smelled better, stayed mold-free longer, and appeared cleaner. The underlying science explains why. Acetic acid disrupts bacterial cell membranes and inhibits mold growth by lowering the pH of the surface. Here's the part worth copying directly into modern practice. Vinegar still works. White distilled vinegar at 5% acidity, which is what you buy in a grocery store, is effective for wiping down counters, removing mineral deposits, cutting through light grease, and treating mold on non-porous surfaces. It's cheap, non-toxic, and doesn't require any special handling. The smell dissipates as it dries. What it won't do is replace bleach for serious disinfection or sanitization of food contact surfaces in a food handling context. If someone in your household is immunocompromised or you're dealing with a genuinely contaminated surface, vinegar is not the right tool. But for routine household cleaning, it works very well and costs almost nothing. Number 5, salt. Salt does several things at once, and frontier households understood this even without being able to articulate the mechanism. It's a desiccant, meaning it draws moisture out of surfaces. It's mildly abrasive. In high concentrations, it inhibits the growth of bacteria and mold by drawing water out of microbial cells through osmosis. And it has a mild bleaching effect on some organic stains. The most practical cleaning use of salt, in a pioneer context, was scouring. Coarse salt applied to a wooden cutting surface, a salting board, a cheese press, or a meat block, and then scrubbed with a cloth or brush, would clean the surface effectively while also sanitizing it to a degree. After scrubbing, rinsing with hot water finished the job. Salt was also used to treat fabric stains, particularly blood stains, which need to be treated with cold water and salt rather than hot water. Hot water sets protein-based stains. Cold water and salt draw them out. This is a piece of practical knowledge that still applies directly today and that a lot of people get backwards. For cast iron pans, coarse salt is one of the best cleaning tools available. For the same reason, sand works. The abrasion lifts stuck on food without damaging the seasoning layer the way dish soap can. The limitation of salt as a cleaner is that it's not a surfactant. It doesn't break down grease the way soap does. It assists in cleaning rather than being a standalone cleaning agent for greasy surfaces. Combined with hot water, it's effective for many tasks. Used alone on a heavily grease-fouled surface, it'll do some work, but won't finish the job. Number 6, beeswax for wood preservation. This one shifts the conversation slightly from cleaning to protecting, which is worth including because the two were closely linked in frontier household work. Cleaning a wooden surface was only part of the job. Sealing it afterward was what kept it from absorbing future dirt, moisture, and bacteria. Beeswax was the primary wood sealant available to pioneer households. Applied warm to wooden floors, furniture, bowls, tool handles, and food storage containers, it formed a thin, water-resistant barrier that protected the grain, prevented cracking, and made future cleaning easier because grime couldn't penetrate the surface. The technique described in period household guides involved warming the wax until it softened, applying it thinly with a cloth, and then buffing it into the surface with a dry cloth to generate heat through friction and drive the wax into the grain. This is not fundamentally different from how modern paste wax is applied today. Beeswax is also food safe, which made it appropriate for wooden bowls, breadboards, and storage containers where chemical sealants would be a problem. It has mild antimicrobial properties, though not strong enough to be a disinfectant. The practical limitation is that beeswax is not a sealer in the modern sense. It does not form a hard film the way polyurethane or lacquer does. It requires reapplication regularly, especially on high-use surfaces. And it doesn't offer significant protection against standing water, just brief water exposure. For anyone working with reclaimed wood, antique furniture, or traditional wooden tools, beeswax is still one of the best treatment options available. It's reversible, food safe, and doesn't alter the natural look of the wood the way modern finishes do. Number 7. Boiling water as the primary sanitation method. This one doesn't get called a trick because it's so obvious, but it was arguably the single most important cleaning tool available to pioneer households, and it's worth treating seriously. Boiling kills pathogens, not some of them. Essentially, all of the bacterial and viral pathogens that cause foodborne illness are destroyed at or below 212 degrees Fahrenheit at sea level, and most are destroyed well below that with enough exposure time. Pioneer households that boiled their water, boiled their laundry, boiled their dishes, and used boiling water in food preparation were protecting themselves through a mechanism that actually worked. Laundry boiling, which involved submerging clothes in a large pot of boiling water with lye soap and agitating them with a wooden paddle, was a standard frontier laundry method. It was effective. It killed lice, mites, and bacteria in a way that cold water washing with limited soap could not. Period accounts from the Civil War era describe soldiers with dramatically higher rates of illness in camps that didn't practice boiling of laundry and cooking equipment, compared to camps where boiling was standard. The practical limitation is fuel. Boiling large quantities of water requires a significant and sustained fire in dry conditions, in areas with limited wood supply, or during periods when fuel was scarce. Extensive boiling was not always practical. That's why it was supplemented with the other methods on this list. But if you're in a long-term off-grid situation with access to firewood, treating your water, your dishes, and your laundry with boiling is not old-fashioned. It's reliable in a way that most improvised cleaning methods cannot match. Number 8. Pine resin and pine tar. This is the most underappreciated item on this list, and it's the one that surprises people most when they dig into the historical record. Pine resin, the sticky material that seeps from cuts in pine trees, and pine tar, which is produced by heating pine wood under low oxygen conditions, were used for a wide range of applications in frontier households. What's relevant here is their antiseptic use, both on skin and on surfaces. Pine resin and pine tar both contain compounds called terpenes, specifically alpha-pinene and related molecules, that have demonstrated antimicrobial properties. Period practice included applying pine tar to wounds, using it as a treatment for skin conditions, and rubbing it onto wooden surfaces, especially in animal housing and wood flooring, as a protective and preserving treatment. As a household cleaner, in the direct sense, pine tar was used on wooden floors and on the wooden interiors of outbuildings, spring houses, and smokehouses. It inhibited mold growth, repelled insects, and helped preserve the wood. Birch tar, produced from birch bark, was also used for similar purposes in northern regions. The antimicrobial properties are real. Modern research has confirmed that terpene compounds from pine and other conifers do inhibit a range of bacteria and fungi. But this is not the same as saying pine resin is a reliable surface disinfectant by modern standards. The concentration, the method of application, and the specific pathogen all matter. What makes this genuinely interesting from a practical standpoint is that pine resin is freely available in forested areas. If you're maintaining a traditional wooden structure, treating exterior wood surfaces with a pine tar solution is still a legitimate wood preservation method that some traditional builders use today. It's not a replacement for boiling water or lye soap, but as a wood treatment and a supplementary preservative, it's grounded in real chemistry. Here's the overall picture. These 8 methods weren't random folk remedies that people happened to use before they knew better. They were practical applications of real chemical principles. Alkalis break down fat. Acid inhibits microbial growth. Abrasion removes fouling. Heat kills pathogens. Desiccants draw out moisture. Sealants prevent future contamination. What's changed is not the underlying chemistry. It's the convenience and consistency of modern products. A bottle of dish soap delivers a reliable concentration of surfactant every single time. A jug of white vinegar delivers a reliable acidity level. A bar of commercial soap is consistent in ways that homemade lye soap never was. The honest assessment is that pioneer cleaning methods were effective, but they were also labor-intensive, inconsistent, and sometimes hazardous when handled carelessly. Lye water can burn you. Boiling large quantities of water over an open fire is a burn hazard. Rendering fat is a fire hazard. These are not complaints. They're context. The people using these methods understood the risks because they lived with them daily. If you're interested in off-grid living, homesteading, or traditional household skills, the methods in this video are worth understanding on a practical level, not just a historical one. Wood ash lye, vinegar, salt, sand, beeswax, boiling, and pine tar are all still functional. They all still work, but use them intelligently. Understand what each one actually does chemically, and don't assume that because something is old, it's automatically safer or more natural than modern alternatives. Some of the most caustic materials available are completely natural. Thanks for watching. If this kind of practical frontier history is what you're looking for, subscribe and check out the rest of the channel. There's a lot more where this came from.